Sri Gurubhyo Namaha. Welcome to our online teaching academy, Ekalaiva. Class 9, Subject Science, Chemistry, Atomic Structure, Matriculation. Introduction. In this part, we are going to discuss about discovery of nucleus, Rutherford's atomic model, limitations in Rutherford model, Bohr's atomic model and limitation of Bohr's model. Introduction. If a small toy, if we give it to a child, the child will search what is there inside that toy. The same thing, atom. Scientists have searched what is there inside the atom. Okay, and many scientists came and they discovered something present in the atom. Let us see what they did. For explaining this, many scientists proposed various atomic models. Now we will learn about subatomic particles and the other atomic models to explain how these particles are arranged in a matter. Okay. So atom is a smallest unit of element and they may independent or they may depend on the other particles. The atoms involved in the chemical reactions. Let us see first nucleus, discovery of nucleus. In 1911, Lord Rutherford scientists experimentally find out there is a particle present in the atom, and he did an experiment like a thin foil, golden foil he has taken, and he passes the alpha particle through that and he observed something in the experiment. Rutherford used the idea of radioactivity to carry out experiments to help him better definition for atomic model, and a experiment involved shooting radioactive alpha particles in a golden sheet. And in this experiment, he observed most of the alpha particles passes straight through the golden foil, but some alpha particles are straight away and some few alpha particles are bounced back. You can see this picture. When he passes through this, some particles goes very straight and some are very slightly reflected and some few are bounced back. So he has using the golden foil because it is malleable and it is very thin. So when passes through alpha particles, you can see here some rays will be very straight and some are slightly deflected and some completely bounced back. By this experiment, he has given some conclusion. Let us see. The atom contains large empty space and there is a positively charged present inside the atom, that is known as nucleus. And the size of the nucleus is very small compared to atom. The electron revolves around the atom and the atom as a whole electrically neutral charge. and the number of proton and the number of electrons are same or equal in the atom. You can see here picture, there is a empty space in the atom and nucleus present inside, that is a neutral charge, and we have a electron revolve around the atom, and proton, electron are thus equal in atoms. And Rutherford model of the atom was same like solar system, how the sun is present and all the planets around the sun, the same, the nucleus inside, all the electrons around the nucleus. Just as in solar system, the sun at the center and the planets revolve around the sun. Similarly, the nucleus is present inside. Around the nucleus, the electron will revolve. Limitations in Rutherford. What is the limitation? Let us see. According to electromagnetic theory, a moving electron should oscillate and continuously and lose the energy. Due to the loss of energy, the path of electron may reduce and finally the electron should fall into the atom. But we know very well the atoms are stable, but if it has happened, the Rutherford atomic model has failed. But atoms are stable, Rutherford model failed to explain the stability of atom. An electron accelerating around the nucleus. So, around the nucleus, the electron is oscillating. So, when it is accelerate, automatically the lose energy and it fall into the atom. So, atom become unstable, but we know atom is a stable. So, the positively charged is nucleus and the negative charge is electron. The electron has negative charge and nucleus has positive charge. So, after Rutherford model failed, next scientist came Bose. Let us see about Bose model of atom. In 1913, Niels Bohr explained about the stability of atom. So, Rutherford atomic model failed in explain the stability of atom. Now, the Bose model will explain about the stability of atom. In atom, the electron revolves around the nucleus in stationary circular path. So, the path is known as orbit or cell. While revolving around the nucleus in an orbit, it may lose the energy or it may gain energy. In an electron, a cell can move higher order or lower energy order. The orbit names he has fixed K, L, M, N. So, that is K cell is equal to 1, L cell is equal to 2, he has named like that. The orbit closest to the nucleus is K shell, and what are the electrons present in the K cell is known as K electrons, and the orbits are associated with the amount of energy, and the Bose are called, that is energy level or energy cells. You can see here this picture, this is the K, L, M, N. K, L, M and N cell. Okay. So, K is the first cell and L, M, N. So, this is the positively charged nucleus present inside atom. how the electrons occupies in K, L, M, N cells. So we have a formula here. N square. So N is equal to first cell. So the K cell occupies 2 electron. When you apply here 2, you will be getting 8. L cell occupy 8 electron and M cell occupy 18 electron and N cell occupy 32 electrons. So when you apply this formula 2n square, you can know how the electrons are occupied in the different cells. Limitations of Bohr's model. One main limitation was that the models is applicable only for the hydrogen and hydrogen-like ions. For example, helium, lithium, beryllium. Like this ions only it is applicable. For the other element or other atoms, this is not applicable. So Bohr's models also will occupy only the hydrogen and hydrogen-like ions. Okay, so this class we discussed about Rutherford atomic model and Bohr's atomic model. Let us see next class. I hope you understand. Thank you, children. To receive our online lessons, please press the subscribe button and you will receive the latest updates.
SRMJV is not just a school, it's a one-time experience.
VM Nagar, Tiruvallur,